Welcome to today's deep dive. Imagine for a second an invisible mathematical shield that just completely guarantees that our power grids, our AI, or even fusion reactors literally cannot crash, like physically cannot degrade.
Yeah, it sounds like science fiction, but that is exactly what we are looking at today. We are going through this massive architectural review of the Dillon curvature framework, specifically the full canon version 6.
Right, and the mission for you, listening right now, is to really grasp how this framework is trying to replace the probabilistic guesswork of modern tech with pure deterministic mathematical certainty.
Exactly, because right now, standard tech relies so heavily on probability. I mean, it is a lot like relying on a weather forecast.
Yeah.
You're basically just hoping a complex system behaves a certain way based on past data.
Okay, let's unpack this a bit, because instead of a weather forecast, this framework acts, well, it acts more like a roller coaster track.
Right.
Like forcing data and energy down this predetermined, inescapable physical path.
That is a great way to look at it. And to actually build that mathematical track, you have to translate abstract data into a physical topography. So the framework completely tosses out standard machine learning models.
Just completely discards them.
Yeah, entirely. It uses something called curvature variable physics, which basically means it treats complex data networks like an actual physical 3D geometric landscape.
Wait, I need a visual here. If we aren't using code to make standard if-then decisions, how does a literal shape dictate where data goes?
So think of the data as a marble. In a normal network, code tells the marble where to roll, but it can still slip or hit friction. Here, the data flows down these physical curvature gradients.
Okay, so gravity basically does the work.
Right. Well, mathematical gravity, they use a specialized math called omega calculus. It maps out all the possible errors in a system and literally bends the mathematical landscape away from those errors.
Oh.
Yeah, it continuously pulls the entire system towards syntropy, which is basically a state of perfect mathematical order. The marble physically cannot roll up the hill into chaos.
Okay, I get the big picture. Mapping macro-level data like a smooth topographic map makes total sense. But what if a literal piece of hardware breaks? Like, say, a biological sensor just short circuits.
Right, the microglitches.
Yeah, how does a macro shape stop a microscopic glitch? I mean, that sounds like magic.
Well, that exact vulnerability is why the framework relies on this dual-scale integrity stack. It seamlessly connects that macro shape to the micro-reality. It uses this thing called the CVP spin overlay.
And that acts as the gatekeeper.
Exactly. Say that biological sensor experiences thermal noise. The actual physical characteristics of its data output change shape. And because the framework is deterministic, that new wrong shape instantly hits a mathematical wall on our roller coaster track.
Ah, because it literally does not fit the curvature gradient anymore.
Bingo. It cannot move forward, so the anomaly is instantaneously frozen right there locally.
See, here is where it gets really interesting to me. It is like a cosmic bouncer freezing a rowdy guest the millisecond they try to throw a punch, before the party even gets ruined.
I love that cosmic bouncer analogy. And while that bouncer is freezing the anomaly, there is another layer. It is called the curvature vector engine, and it logs that exact micro event onto an immutable integrity plane.
So it creates a permanent geometric cast of the error, which means regulators get, a 100% accurate deterministic replay?
Exactly. They can see the system's exact history to figure out why the sensor failed, and the rest of the network never even feels a ripple.
And since this relies on universal math constants instead of just domain-specific code, this is not just some software patch. This applies directly to the physical world around you.
Oh, absolutely. Like in telecommunications right now, they're using this geometry to stabilize 6G networks. It is a process called toroidal refractance.
Wait, toroidal, like a donut shape?
Yes, exactly, a donut shape. By mathematically folding the signal data into that torus shape, they completely eliminate physical friction. It stops interference between molecular narrow devices and massive cell towers.
So the signal just glides through the interference because the geometry resists degradation. That is wild. And the sources mention this completely rewrites the rules for energy and defense, too.
Big time. Look at fusion reactors. Instead of using brute force magnetic fields that can fail and let volatile plasma escape, they trap the plasma using geometric topology. The plasma has to flow along those inescapable gradients.
And militarily, there is Project Geodesic Shield, right? Which uses this to track silent, non-communicating drone swarms.
Right, because it doesn't even listen for radio emissions. It reads the physical disruption those drones cause to space-time itself. Just by flying through the environment, the drones alter its geometric curvature.
So if you're wondering why this matters the next time your cell drops a call or the local grid flickers,
Yeah.
I mean, we are looking at a profound epistemological shift here.
We really are. We are moving from merely hoping complex systems survive the chaos of the real world to mathematically mandating their stability, literally through the geometry of space itself.
Yeah, failure is simply no longer an accepted variable. Degradation becomes mathematically impossible. Which leaves us with a final thought for you to ponder today.
Oh, I know where you're going with this.
Right. If we can use curvature geometry to guarantee that autonomous AI or fusion reactors and telecom grids will never collapse, could we one day map out and stabilize highly volatile human systems?
Like global economic markets.
Exactly. Could the chaos of the markets be smoothed out by those exact same mathematical gradients? No more financial weather forecasts, just the inescapable physics of the roller coaster track.